All right, thank you for joining us today. And in this video, we are going to take, I think, 5 examples and we are going to go through together. Let's jump right in. So, using the graph to estimate the following, right? So, we are going to use this graph here to estimate the following limit, right? So, we are going to take them one by one and then help you to understand it. Okay, let's start. So, the idea is that now we want to find limit as x is approaching negative infinity. So you know that this is our x-axis, this is our y-axis. So when we are saying that x is approaching negative infinity, we are trying to look at wave going this way. So for wave going this way, we need to look at the x values. So with the x value, we can see that we have 3 here, right? So after the 3, we need to look for a graph that is going negative infinity, right? And then the graph that is going negative infinity is this graph, and we can see that it's going negative infinity and it is approaching this line right here, right? So we are going negative infinity, but we are approaching the line that I just indicate on the top there, and this line right here is equal to what? 4. So it means that limit as x is approaching infinity of f of x is equal to 4. Very simple. We go negative infinity, but we are approaching this line here. It means that we cannot cross that line, right? Let's look at when we are approaching, s is approaching infinity. So first we need to look for where the positive side is. This is the positive side, and then the only graph that is going to the positive side is this graph, right? And we can see that this graph here is going down, down, down. So since it's going down, meaning that it will go to negative what? Infinity. So this is going to give us negative infinity, right? Let's look at limit as x is approaching negative 4. Now for us to conclude on that, we need to look for limit x is approaching negative 4 of f of x, and then from the negative side, and then also limit as x is approaching negative 4 from the positive side of the function, right? So these are the two things that we need to do. So what we need to do is we need to go and look for negative 4, right? We draw a vertical line on the negative 4, and then we try to figure out things. So let me draw this line here. Let me draw this vertical line here through 4, right? So with negative 4, now with this line, as I said from some of the previous video that we did, I said for you to now look for the limit on the left side, look for the graph on the left side of negative 4 and go along the graph towards this line here. So we can see that this is the graph on the left side. So we need to move along this one towards what? 4. But when we get to this line, we can see that we are here at this line. Then we trace it to the what? The y-axis, which is giving us 3. So this is going to give us 3, right? Good. Then when you finish, we need to look at the right hand side, the graph. So the right hand side graph of negative 4 is this one, and we move towards the line, and then also we get it here and we trace it, we are getting 3. So this is also going to give us 3. So now we are going to conclude that this is going to give us 3 because the left and the right is equal to what? 3. Good. Now what is f of negative 4? So with f of negative 4, what we need to do is we are on the same line. So let me clean this line here. We are on the same line, but we need to look at the one which is what? Closed. Now you can see that we have one hole here, we have another hole here, but this hole is what? Shaded. So on the same negative 4, we have this and this. This is called open, this is called open, this is called close. So we are going to choose the close, right? So f of negative 4 is going to give us let me trace it to the line 6. So we are going to have 6 right there. Let's go through x is approaching negative 3 from the negative side. So 3 from the negative side. Okay, good. We have the line already. So from the negative side is this, right? So we need to look at the graph on the left side that is coming close to this line. So when we are moving from the left side and we are getting close to 3, we can see that this is actually moving towards negative infinity. So this is going to give us negative infinity. Let's look at the positive side. This is the positive side. So we need to look at the graph that is coming to this line from the right side. So we can see that this is the graph, but this is actually moving toward positive infinity. So this is going to give us positive infinity. Let's look at 2 from the positive side. Where is 2? Okay. So we have 2. I will draw my line, right? So when I'm done with my line, we want to look at the positive side. So this is the positive side. We need to look at the graph on the positive side. Then we move along on the line or on the graph towards this line here. So we have this graph here. So we move along here. When you get here, then we trace it to the y-axis. So it's going to give us negative 2. So this is going to give us negative 2. From the negative side, this is the negative side of the graph. So we need to look for the graph that is coming from the negative side. So this is coming from the negative side towards this line. So I'll move from this. When I get here, then I'll move here. So we are going to have 3. So that one is going to give us 3. And then this one does not exist because the left and the right are not the same. So that is the limit, right? That is the limit for this question, right? Let's move to the next one. The next one here, we want to find the revenue of the function or the revenue function. So given the price demand equation, find the revenue. So the first question is, what is the formula for finding revenue? So we know that revenue is equal to price times what? Quantity. But the quantity, we represent the quantity by x. So this one is going to simplify to p times x, right? So since our function here is in terms of x, then this one should be in terms of only x only. So it means that we need to go and look for p and come and do substitution here. But we can use this one to find for p. So when I pick x is equal to 500 minus 25p, then I'll make p the subject, right? So what I'm going to do is I'll move this one here and then I'll move this one also here. So when I move negative 25p to the left side, I'm going to have it to be positive, which is equal to, I'll maintain the 500 and then move the x to the right side, which is going to give us negative what? X. Then the next thing to do is I'll divide this one by 25 and divide this one by 25. So 25 will cancel the 25. So we are going to have p to be equal to 500 minus x divided by 25. So this is going to be the price. So now if this is the price, then we are going to have this one to be 500 minus x divided by 25 all times what? X. So this is going to be the revenue. If we want to simplify, then we are going to have, now this x here will multiply the top, right? So we are going to have 500x minus x squared all divided by 25. So this is the revenue function. We call it revenue function because it's in terms of what? X, right? Now we want to look at the marginal revenue function. So the marginal revenue function is very simple. If you want to find the marginal revenue function, then we just need to what? Differentiate the what? The function. So the marginal revenue function is actually r prime of x. So we need to differentiate this function right here. So now how are you going to differentiate this function? Now, as I said, if you want to differentiate a function and you see a constant multiplying or dividing, you can factor it out. So this one, I have this 25 dividing, right? So the function is divided by 25. So I will factor the 1 over the 25 out, which is going to be left with 500x minus x squared. So we are going to use the power rule to differentiate this. So how are we going to do that? When I differentiate x, what am I going to get? So when I differentiate x, I get 1. So it means that I'm going to have 500 times 1 minus, when I differentiate x squared, what am I going to get? So as we learned from the power rule, we said power rule x squared, this is the same as when you want to differentiate, this is going to be 2x squared minus 1, which is going to give us 2x. So drop the 2 down, maintain the function, and subtract -1. So this is going to give us 2x. So I simplify this, then I have 25, 1 over 25, 500 minus 2x. So this is what I'm going to get at the end of the day, right? This will be the marginal revenue function. Now let's look at the C. If 20 items are currently being produced, estimates the change in revenue for producing one more item. So don't forget, when we talk about um, the marginal cost function, which is equal to mx plus b, don't forget the m here is the what? It is the marginal cost, or the variable cost, which depends on x, any change that is going to happen, right? So if x is changing, like the quantity that we have here, if x change, the cost is also going to change, right? So if the question is being asked for, we want to know the change in revenue, then the change in revenue, we are going to use the marginal revenue function. Why? Because we are talking about change, and change goes with what? The derivative, like when you differentiate the function, right? So here we are going to use x is equal to 50, and we are going to plug this one inside our marginal revenue function, which is r prime of 50, which is going to give us, we had the function here to be this, so let me write this one here, r prime of 50. So I'm just going to, x is 50, so I'm plugging in x. So I'm going to have 1 over 25, then 500 minus 2 times 50. So 1 over 25, then 500 minus 2 times 50 is going to give us 100, and then 1 over 25 times 400. So what are we going to get? So this is going to give us 60. Good. All right. Now let's look at D. If 100 are currently being produced, estimate the change in revenue from producing 5 more items. Okay, so we are going to use the same, marginal revenue function. So here now our s is equal to 100, which is equal to, so now we are going to have r prime of 100, which is equal to 1 over 25, then 100, 500 minus 2 times 100, then we are going to have 1 over 25, 500 minus 200, and then this one is going to give us 1 over 25 times 300. Then what is 300 divided by 25? We are going to have 12, right? So we are going to have it to be 12. Now we are not done. Why? Because now the question is asking us 5 more items. Now this is for producing 1 more item. So here the 12 here is the cost, the marginal cost, like that you are going to incur, is like you are going to get it in producing only 1 item. Like when you produce only 1 item, this is saying that we should produce 5 more items. This one, we had the 16 to be the result because we wanted to produce 1 more item. This is what you are going to get. So since this is 5 more item, then our final results will be 12 times 5, which is going to give us 60. Right. So this is what we are going to get as a result of we producing 5 more items, in addition. So that's what we are going to get. We should get 60 from there. Okay, so now let's look at the next question. Okay, so the next question, we want to look at finding the derivative of the following function, right? Good. So here we are going to apply the power rule. We are going to apply the power rule. So here y prime is equal to, so as I said, the power rule says that if I have f of x to be equal to x to the power n, then f prime of x is equal to, bring the n down, times maintain the function x to the power n but subtract 1. So that is the power rule. So if I have this one, I'll maintain my 3. I want to differentiate x to the power 4. So this is going to be, bring the 4 down, write x to the power 4 and subtract 1, which is going to give us 4x to the power 3. So this is going to give us 4x to the power 3 minus 7. Then this one will help us go quick. This is going to be 3x to the power 2. So I drop the 3, I subtract 1. So that's what I'm going to get from there. Then let's look at plus 2x squared. So when I differentiate x squared, I'm going to have 2x. I drop the 2, I subtract 1. Now plus 5, when I differentiate x, I get 1, minus when I differentiate a constant, I get 0. So simplify this and we get 12x to the power 3 minus 21x squared plus 4x plus 5. So this will be the result for finding the function from there. So let me shift this one here small. Now let's look at b. Now because we want to use power rule, I will try and simplify this function. So this is the same as x to the power 3 divided by x minus x divided by x, right? So since the function is divided by x, I can split them into x cubed divided by x minus x divided by x. And this is going to give us x squared minus 1. Good. So now this is our new f of x by doing the simplification. Then what will be f prime of x? Power rule. X squared is going to give us x. And when I differentiate 1, I'll get 0. So my final result should be 2x. Right. Now let's look at this one too here. So as I said, always simplify your function so that you don't struggle. So this is the same as 6 to the 6 times y to the power 1 over 2. So using the power rule, g prime of y will be equal to 6 times 1 over 2 y minus. So y2 minus 1, right. Then this is going to give us 3 y to the power negative 1 over 2. That's what you are going to get. And I show you my trick for doing fractions. 1 divided by 2 minus 1. This is the same as divided by what? 1. So 1 times, so you write this division line here. Then 1 times 1, you put it here. Minus 2 times 1, you put it here. Divided by this 2 times 1 here. And then you get something like this. So this is negative 1 over 2, which we had it right there. So this will be the derivative. If you want to simplify, this is the same as 3 times 1 over y to the power 1 over 2. And this is the same as 3 divided by root y. So that's what you are going to get. Now let's look at this one. This is so powerful. Why? Now I can see that the function here does not involve t. We can't see t here. There is no t in this function. So this is a constant function. So g prime of t is equal to 0. That's what you need to know. So always pay attention to that. That one will give us 0. Now 4, if the equation of the tangent, if the equation of the tangent line to a function f of x at s is equal to 3 is this, what is f prime of 3? So they are asking us for f prime of 3, but we know that f prime of 3 is actually the slope, right? Because if I want to write this one right here, if I want to write this one here, f prime of 3 is actually the slope, and they've given us the equation of the tangent, which is equal to 2m minus 5. Remember, this is the same as y is equal to mx plus b, right? And our m here is the slope, and in this question our m here is the same as the f prime of 3. And then when you compare this to this, we can see that m is equal to 2. So f prime of 3 is 2. Very simple. Very, very simple. You don't need to do a whole lot of work. What you need to know is this equation right here is the equation of the tangent line. So you don't need to differentiate this and then plug in 3. Maybe when you do that, you are going to get it right, because when I differentiate this, I'll get 2, and when I plug in 3, I'm going to get 2, which is also right. But the best way here is know that this is the tangent line, yes, equation of the tangent line, and this will be the slope, and then the slope is the same as f prime of 3, right? Let's do the last question here, 5. Now evaluate the following limit, right? We want to evaluate the following limit. So as I said, anytime you want to evaluate limit, the first thing that we need to do is we do plug in. We just need to do direct substitution, and then we check what is going to happen. And this, since this is a fraction, and yeah, this is a fraction, we are interested in the what happens to the denominator, right? So we are just going to plug in the -3 to the denominator and find out if it's going to be 0, right? So if it's not 0, then what we need to do is we need to, then we can now plug in the -3. But if it is 0, then we need to simplify before we do what? We do plug in again. So let's pick x squared plus 8x plus 15. So you saw that so this is the denominator, right? I want to check if it is not 0. If it is not 0, then I can do direct substitution. If it is 0, then I need to simplify. So let me plug in -3. So -3 squared plus 8 minus 3 plus 15. So this is going to be 9. Then this is going to be minus 3 times this one will be 24 plus 15. So 9 plus 15 is 24 minus 24, and this is going to be 0. So since the denominator is going to be 0, we cannot do what? Direct substitution. We need to what? Simplify. So let's try and simplify. Now for us to simplify, first what we need to do is we need to try and simplify this function here. So how am I going to simplify this one here? X squared plus 8x plus 15. I need to look for the multiples of 15, or let me say the factors of 15, that when I add, I'm going to get 8, but when I multiply, I'm going to get what? 15. So we can think of 3 and 5. 3 and 5 are factors of 15, and when I add, I'm going to get 8, and when I multiply, I'm going to get what? 15. So this is the same as x squared plus 3x plus 5x plus 15, which is, I will factor x out, this will be 3, plus I'll factor 5 out, this one will be 3. So this is the same as x plus 5, x plus 3. So that is the idea. So now the 3 that I brought here, 3 times 5 is 15, but 3x plus 5x is equal to what? 8x. And then here I have factored one of the x out. So when I factor x out here, when I factor one x out here, it's like dividing this one by x. So it will cancel one of the x, which will be left with only one x. Divided by x, it will cancel, it will be left with this. Then this one too, when I factor 5 out, is the idea that divide this one by 5, divide this one by 5, and you get this. Then since this and this are common, then I can pick one of them and then also pick x plus 5 as one of them, right? So that is the factorization there. Now let's look at the top here. X squared minus 9 is the same as x squared minus 3, 9. Then we use the idea of difference of two squares, which is going to give us x minus 3, x plus 3. So this is the numerator, this is the denominator, right? So we can write them again. This is the same as limit x is approaching -3, right? The numerator is x minus 3, x plus 3. So I can clean this. Good. And then the denominator we got x plus 5, x plus 3. So now we can see that this can cancel this. So we are going to have limit x is approaching -3, x minus 3 divided by x plus 5, and this is going to give us -3 minus 3 divided by -3 plus 5, and we are going to have -6 divided by 2, right? Then -3 divided by 2, -6 divided by 2 is going to give us -3, right? So if you want to learn more on evaluating limit of rational function, you can check out my videos on limit. I have playlist on limit, which when you check through, you will see that evaluating polynomial function, rational function, trig function, we have all of them there, so you can check them out. Now I want to find limit of this function, but this one as x is approaching what? Infinity. And this is so nice. How do you do this? This one you don't need to do a whole lot of work, right? What you need to do is look for the polynomial function here on the top and look at the polynomial function here on the down. This is what I'm going to do. This is the same as limit x is approaching infinity. What am I going to do here? On the top, I will just write the function which is with the highest degree, right? So on the top here, the function with the highest degree is 2x squared. So I'm just going to take this one out because the highest degree from the top is just 2x squared. I look at the denominator 2 and then I see that 3x squared is the one with the highest degree. So I'm not going to write this one. But let's assume that this is to the power 3. Then I'll write here minus 7x to the power 3. Good. So this is what the beauty for the idea of evaluating limit as x is approaching what? Infinity. So this is going to give us, so x will cancel x squared. So we are going to have limit x is approaching infinity 2/3. And we can see that the idea of x is approaching infinity, this function here does not depend on x. So we are going to have 2/3. So one thing that you need to know is a limit of a constant is the same as a constant. But we saw that when you differentiate a constant, you get 0. But a limit of a constant is the same as a constant. Right. So should I give you this for you to try? Okay, you can try this one and then paste your answer in the comment section or write your final results in the comment section. It's the same idea with this one. Pick the one with the highest degree on the top and then the down and paste your results in the comment section. All right. Now let's look at this one. We want to look at limit as x is approaching 2 from the negative side, right? From the negative side. The idea is that here, when I plug in 2, as I said, when I plug in the 2, I'm going to get the denominator 0. So the idea of doing direct substitution will not work. Now, don't forget, if you see minus here, the minus here is just telling us that we are approaching 2 from the negative side. It doesn't tell us that this is -2. No. So when you see negative here, it tells us that we are approaching 2 from the what? The negative side, right? So here, because when I plug in 0, 2, I'm going to get it to be undefined. What I need to do is I need to pick value from the negative side. So this is 2, but the negative side, we are talking about the negative side. So I'm going to pick a value close to 2 from the negative side. So I can pick something like 1.9, which is almost close to what? 2. Then I'll just do the substitution from there. So this is going to give me something like 2 times 1.9 plus 1 divided by 1.9 minus 2. Now, I'm not going to solve this, but I'll show you something. You see, this is positive value. This is also positive value. So when I add the 2, I'm going to get the top to be positive, like a positive number, right? Now, 1.9 is less than 2. So when I subtract 1.9 from this, I'm going to get negative 0.1, which is giving us negative. So this will be divided by negative. Positive divided by negative is going to give us negative. So it means that our result here is going to give us what? Negative infinity. Why? Because we remember that when I put 2 here, the denominator is going to be what? 0. And the idea is that we cannot simplify. So since we cannot simplify, then it means that since we are getting 0 at the denominator, we are going to get it to be infinity. But we don't know whether we are getting positive infinity or a negative infinity. So that's the reason why we need to pick something from the left which is close to 2, and then we plug it in and see whether we are going to get a negative or positive. If we get negative, it means we are going to get negative infinity. If we get positive, we are going to get positive infinity right there. Right. Now let's look at this one. I have another video too on this one, rational function and a radical function, in my limit, video. This one, the idea is that when you have a rational function and then a radical function, it's very simple. What I'm going to do is I'm going to multiply this function by 1, like 1 divided by 1. But I'm not just going to do it just 1 divided by 1. What I'm going to do is I'm going to look at the function here, the one with the radical, the root. So I can see that I have this one here, I have this one here, but the one with the radical is the one at the top, right? So I'll pick that one, and x2 minus x plus 1. So when I pick the one with the radical, I will change the sign that is separating the radical from the other function to plus. So if this is plus, this one will be minus, divided by the same content, like the same 2 minus x plus 1, so that this will divide this and I'm getting 1. That is the idea. So now let's simplify. Limit as s is approaching 1. Now one thing that you need to know is we will definitely do cancellation. So when you want to simplify this equation here, you just simplify the one that has a radical here and a radical here. That is the idea. So the top and then down. When you look at the down here and then down here, you can see that this down does not involve a radical, but this one involves a radical. We are not going to simplify. We are just going to write it in this form. X minus 1 root of 2 minus x plus 1. With the idea that when we simplify the one with the radical, we can cancel out, right? Because if we are able to cancel this out, then this one is going to help us, because it's this one that is causing the problem of me doing direct substitution, getting the denominator to be 0, right? So that is the idea. So now let's look at the top. Root of 2 minus x times root of 2 minus x is going to give us 2 minus x. The idea is that if we have 2 times root a times root a, this is the same as root a times a, which is the same as root a squared. Then this one will cancel this and you get a, right? So since they are the same, you get one of the values under the bracket, right? Then this one here will multiply this one. So I'm going to have plus root of 2 minus x. Then this one too will multiply this. Then I'm going to have minus root of 2 minus x. Then negative 1 times 1 is going to give us negative 1. Very nice, right? Very nice, right? So this is what you are going to get at the end of the day, right? This is what you are going to get at the end of the day. So now let's look at what we can do now. So now this will cancel this, because this is positive and this is negative. So we are going to have limit x is approaching 1. Now this will cancel this. Now look at something here. 2 minus 1 will give us 1. So we are going to have 1 minus x divided by x minus 1 root of 2 minus x plus 1. Let me write this one well. Two minus x plus 1. Now we cannot cancel this and this, because if it is positive, then we can say that it's what commutative. But since it's minus, then for us to cancel, then we need to do something small. Limit x is approaching 1. Now I need to factor minus 1 out, so that I'll have minus x minus 1 So that when I multiply it through, when I multiply the minus through, I get what is here, right? Then now I divide it by x minus 1 root of 2 minus x plus 1. Then now this can cancel this, which is very nice, right? So let me just move the solution up small. I will not be able to move the question too, but let me move this one up here. So I'm going to have limit x approaching 1 minus 1 divided by root of 2 minus x plus 1. So now I can plug in the 1, right? So when I do that, I'm going to have negative 1 divided by negative 1 divided by. When I plug in the 1, I'm going to have root of 2 minus 1 plus 1. So this is minus 1 divided by root 1 plus 1, then minus 1 divided by 1 plus 1, and this is minus 1 over 2, right? Very simple. I'm going to get minus 1 over 2. So this is the end of the video. The questions that I left them out for you to put them in the comment section, make sure you put them in the comment section. I'll check it out. If you are right, I'll give you thumbs up in the comment section.